Well, hello everyone, and welcome to the February 2023 edition of the St. Louis Java Users Group. So for those who don't know, the St. Louis Java Users Group is an informal group, and we don't really maintain a formal membership list. Normally, we meet on the second Thursday of every month except December, when there is no meeting. There's just too many things going on over the holidays for us to be able to schedule a meeting in December. When we meet in person, you can join us for food and social at 6 p.m., and the meeting will start at 6:30 p.m. When we meet in person, our normal meeting location is in the OCI training room, and that's at 12,140 Woodcrest Executive Drive, Suite 310 in St. Louis, Missouri. I'd like to introduce to you the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Alsfo, that's me in the center, Wei-Chi Gao, and Kathy Zwang. And we also, as of tonight, have a new Java Users Group Steering Committee member. We don't have his picture up yet. It's Robert Levitt. He's been with us for a long time attending. His attendance record has just been stellar. You can email all of us on the St. Louis Java Users Group Steering Committee at the email address shown at the bottom of the slide. That's javasigsc@ociweb.com. The St. Louis Java Users Group would not be possible without the support of our sponsors. So I'll just walk through here from left to right, top to bottom. Object Computing Incorporated is our original sponsor. They've been with us since 1997 when this group was formed. They've supplied and filled in all kinds of gaps whenever we need them filled. JFrog has been an excellent sponsor. They sponsor the Meetup subscription fees and the Zoom account, which makes this remote meeting possible. Now, as far as the Meetup subscription fees go, it's free for you to sign up and attend meetings, but it does cost the group some money to be able to have a web page on the meetup.com site. Signature Consultants and Adaptive Solutions Group are headhunters, and when we meet in person, they have been sponsoring food. So if you are looking to fill a Java position or are looking to be hired as a Java developer, contact them with just a quick Google search and let them know that you found out about them through the St. Louis Java Users Group. At the end of this meeting, we will be raffling 2 JetBrains licenses. And if you're watching the recording, I'm sorry, you must be present to win. It will be at the end of the meeting. Elastic sponsors some gift cards as well, which we'll raffle as soon as we get back to in-person. We're not sure when that will be. Intertech sponsors the famous Screaming Flying Monkeys coffee cups and mouse pads, and we'll give those away next time we're in person. Again, we're not sure exactly when that will be. At the end of this meeting, we will be raffling 2 Manning e-books of your choice, and again, you must be present to win. And Pearson will often sponsor physical books as well for our raffles. So thank you for all of our sponsors. As far as announcements go, No Fluff, Just Stuff is coming to St. Louis. It's the Gateway Software Symposium that will be March 31st through April 1st. And if you want more details about that, just go to the web page there that's on your screen. That's nofluffjuststuff.com/St. Louis. And we have a JUG discount code for people who would like to attend that meeting, and it's there on your screen there, NFJSJUG100. And I also sent out an email to the email list that has all the links to the information about that conference. Hopefully next month we will be raffling a No Fluff Just Stuff ticket for people who would like to be able to attend that conference. Also, DevNexus 2023 is coming. They're one of the largest Java users conferences in North America. And that will be April 4th through the 6th in Atlanta, Georgia. And for details on that, you can just go to that website right there. That's devnexus.com. You may have seen this other email that I sent out to the list as well. The Developer Week 2023 conference is coming. Now, there's going to be two different versions of that. February 15th through the 17th will be in person in Oakland, California. And the virtual version of that will take place February 21st through the 23rd. I was contacted by the hosts of Developer Week, and they are offering 25 free, that's right, free open passes to attend the virtual version. And you can get a discount on the pro version, which is the in-person version of that. It's a $100 discount. So if you want the details about how to get those free open passes, if you're on the email list as part of the Java users group, you should have that email. But if you missed it, go to our meetup page. That's meetup.com/gatewaychug, and you will see some menus there. Go to the message board, and both of the announcements for both the No Fluff Just Stuff conference as well as the Developer Week conference, those links are posted there in the message board on our meetup.com/gatewaychug website in the message board. You'll have to look for that link there. You should be able to find it in the menus. So as far as upcoming presentations go, on March 9th, 2023, it will be Open Rewrite. Yeah, the code fixes itself, plus all the dependencies. Wow, isn't that a miracle? By Jonathan Snyder, and he is the CEO and co-founder of Modern. So he's given presentations at the Java Users Group before, so I'm looking forward to that one. And you can go ahead and start signing up for that one. As presentations are scheduled, we post them on the meetup.com/gatewaychug website, so you can RSVP for that one as well right now. So if you want to keep up with our schedule, like I was saying, just go to meetup.com/gatewaychug for any updates to the presentation schedules and location. If you are interested in giving a presentation, or there's a particular presentation you would like to see, or perhaps you'd like to sponsor the Jug, just send an email to the steering committee at that email address I said before. Again, that's javasigsc@ociweb.com. So I think at this point we're ready here for tonight's presentation on Not Your Father's Java and Not Your Mother's JavaScript. So I'm going to click the Stop Share button and let Dimitri take it from there so he can share his screen. Take it away, Dimitri.
Thanks, Bruce. Should work now.
Yes, I see you very clearly.
Thanks. So hello. Happy to be here on this very Jug that exists longer than the period that I'm going to cover in my talk. This is an interesting situation when I hope there are new people who really didn't see the code that I've seen 20 years ago. We're going to talk about Java and JavaScript. Well, the idea of this talk is to have a lightweight, very subjective view on how those two technologies developed during their lifetime from my perspective and how I participated or interacted with them and what are impressions from the changes that happened and when they happened and it's also interesting. So I worked at a company named Bellsoft. You probably know Bellsoft as one of producers of OpenJDK distributions. Our distribution is called Liberica JDK, and if you build containers with Spring Boot using standard tools, you'll get a container containing Liberica JDK. And since Spring Boot 3, you can also build a container where your application is packed as a native image, and this variant is powered by the Liberica Native Image Kit, which is an assembly of GraalVM Community Edition. So I contribute to OpenJDK, but before doing that, I tried different things, different lines of Java programming, like mobile and server development, and also faced development in JavaScript and other languages, of course. So it really happens. Well, and honestly, stolen picture from the internet, it's a typical view. Still many people share that there's no difference between Java and JavaScript. That's probably the same thing, just name slightly different. Well, there are many similarities, and what I observed and what I was surprised with, especially last year, how many things in fact became very, very similar in Java and JavaScript. They started as so first Java has been developed and it got its code name in 1995, and later, a year later, it has been released. And about the same time, the language initially, it was called LiveScript or something similar, has been released by Netscape in its product at that time. That was Netscape Navigator. And to make it more attractive, the syntax and the name was made very, or at least somehow similar to Java. What's interesting is that I work mostly within OpenJDK space, and OpenJDK as an open source project really started at 2006 and was fully open sourced a bit later. And from another hand, JavaScript was open sourced in 1998, and even though there already were many free software like Linux and open source Unix systems, still the term open source itself was invented about the time. So we now can celebrate the anniversary of open source. So open source, unlike free software, is something that's understandable by large corporations, because if it's not free, probably you can earn some money by developing open source, which is now the thing that many organizations and people do. And we know that Java has standards, has versions of language specifications, and they are really called boring, like, well, Java language specification or Java virtual machine specification. Not so boring with JavaScript, because this standard is called ECMAScript, and it's standardized with codename ECMA 262 by a group named TC39. But still, there are versions of this standard. And what's interesting, you can find all the implemented or currently being developed proposals to the standard on web pages, and you can also execute or transpile the most or more modern JavaScript to older versions using Bible. Well, Java is really great. So from the very beginning, it has garbage collection, it has support for writing multi-threaded programs to perform synchronization, so the data can be correctly shared and passed between threads. And for all these years, Java is backward compatible, which is a really important and property that's hard to achieve. Well, from another hand, JavaScript from the very beginning was a fun because everything is a function. If we need to create a class, well, we create a function which we can later call using the special operator new, but in fact it can be called without new as well, and inside that function we can declare or create fields and other functions, member functions, which we can call later. And there's also a magical prototype. Since the early browser versions of JavaScript, where it immediately started to play as it appeared in the browser and it continues to exist in browsers, there were other different magical objects like window or well, documents. Well, this is not so complex magic, because after a few years or some years of development in JavaScript, people started to make fun of it, just trying to invent all possible combinations of different code patterns that look like nonsense, but still produce some result. So I just listed two famous talks here, but you can probably find many more of them trying to asking you to guess what outcome you'll see after some weird JavaScript line. So then it all started. We'll go through the evolution of specs, mainly for Java and JavaScript, because it's interesting how well, I wouldn't say competed with each other, but how very similar features developed in more or less the same time. So 1997, it all started for version 1 of specifications, and for Java it was even 1.1, not even the second spec. There was 1.0.2. But anyway, from the very beginning, JavaScript was very dynamic, and it has eval function, which is still really important and actively being used for many development purposes, and it kind of a solution for many non-typical problems. Java had many enterprise features like serialization, ability to call remote functions using built-in tools. It had reflection. Java beans were introduced at that time, and very rapidly Java got a performant virtual machine. Not as performant as it is now, and it was a different virtual machine at the time, but it started to utilize the idea of just-in-time compilation to speed up the code, to use the precise type information even for the strongly typed language. And while it became even more enterprise with a thing like Corba, which then existed for a very long time, we'll see when it finished its existence in Java, but that took a long time. And the class library with standard data structure is one of a very powerful sides of Java, because you can easily take a ready-made collection without plugging in any extra library that provides an abstraction. Even a simple hash map is not a trivial thing, because in JavaScript everything is a map, right? Or you can deal with arrays, but more sophisticated data structures, they need to be written by hand, or at least it was so at that time. So in 1999, I used some imperative languages. I used to use them for programming. I already was aware of HTML, and that was an interesting concept of a markup language, because it's still a technical thing. It's a specified language, but it's not a language that instructs computer to perform some visible actions. Those actions are about drawing or uh, making a layout of elements. And there's also a concept of DOM model. Well, web at that time started to become complicated, because there was JavaScript and later, or about the same time, CSS. And those are still major components of web, and they are different languages. Well, even after Netscape became Mozilla as an open source, there was a kingdom of Internet Explorer. And surprisingly, it implemented actual specification of JavaScript very well at that time. But that was ECMAScript 3, and it existed for many years after it has been released. And there were certain extensions for every browser, still as it is now, but that was much more painful. They were, well, really incompatible, or very specific to each browser, not a case when just different implementations start to implement different parts of new spec. And one of the parts was MS XML library that preceded the real XMLHttpRequest implementation. And it was an ugly thing, an ActiveX component embedded in Internet Explorer of the old versions, but it worked. So if you build systems that were expected to work with only one or two browsers, that was quite normal to create one or two implementations using different objects specific to that browsers to perform tasks like querying data from web. And yes, at that time, GSP was also created where you could embed some Java code, which actually was compiled by JavaC or other later other Java compilers. So you could mix your web page code with some Java code, but that Java code was executed on server. So it's classical web 1.0. After that, well, yes, and if we remember the very old good code that we used to write, all that boilerplate without generics, without other syntactic sugar, it was really painful. But because of garbage collection, because of that great enterprise features, people still started to switch to Java from other languages. Like I remember switching from C++ and other languages to Java because of that. So you had to write more code, but you got rather good results in the end. And again, Java is not that trivial. I think from the very beginning, people started to construct puzzles for Java. There are many different puzzles. I think there's a great talk from 2012 by Joshua Bloch, but there are others. So here is when I started to program in Java and JavaScript as well. It was very unexpected for me. Just my friends, my colleagues asked, okay, we have a new project here. You can join. We only have, at the time, what was 2 persons working on it. And inside there, Java 1.4 was used, which performed XSLT transformations and XPath selections on XML data. And that XML had different formats. Some structures described the domain data, which was a system that helped to distribute musical, just to distribute songs and to collect payment for that songs, unlike Napster, that which also started with NA. It was called Navio, and it helped different big titles to sell their legal music. So the data was there, and there was, of course, some exchange inside the system between front end and back end, called server side at that time, or inside the back end. There were some issues or goals required to perform authentication inside the system or outside it. In particular, SOAP, that's mentioned in the abstract of this talk. We used it not only inside the system on the backend, but also SOAP messages were constructed on client and then sent to the server. And the same in the other direction. So to achieve that, we really used a new technique called Ajax. And we even at that time didn't know the word Ajax. We just invented the technique in parallel, so we knew that there are such objects that can be used to asynchronously get the data and then to work with that data. And the major format at that time, the most modern and perspective format used for the data was XML, as I mentioned. It could be translated even using special devices, or it could be transformed using built-in Java tooling, which again made Java very popular at that time. Then J2EE appeared, and that really helped a lot systems like the one that we created, because you can easily write what application server or servlet container provides, or you could easily not just create servlets, but just you could send mail or perform other basic tasks that before required a lot of effort to implement. So it was really nice. And what I didn't know at that time, that there's a framework called Spring. Spring 1.0 has been released in 2004. So we used to think that Spring is, well, something not necessary, or it's a modern thing, but it exists for a very long time. And it's interesting that now our company works with VMware and helps to provides runtime for Spring. Then finally, after some painful programming in Java 1.4, we migrated to Java 1.5, where the major thing was generics, of course. But also we started to use annotations and meta programming, and it had a really great connection between what we've studied before in university about metaprogramming and what Java offered us. And also, of course, there was different syntactic sugar in Java 1.5. So in 2005, Spring 2.0 has been released. And if you may notice, as annotations were presented only in Java 1.5, Spring 1.0 operated only XML data, only XML configurations. And still, all this XML magic and no JSON yet here. But it was really a thing to add some Web 2.0 to your static pages. Because instead of constantly seeing a lot of page, you saw maybe not instant, but a work that happened on your page as if it was a real desktop program. And that was kind of new at that time. And in JavaScript, you could easily access your DOM elements, including DOM elements inside the XML that server sent to you. Well, now if we come to a more modern Java, at that time that is covered by a part of timeline on this slide, I started to work on a system that was a social network where you mostly exchanged pictures. Very similar to Instagram, but you probably don't know the name of this social network. And Java 1.6 had an interesting feature. It had a JavaScript engine. So the popularity of both languages grew very rapidly, and people started to want some interoperation, to use a single environment and to use the preferred language. For browser environment, it still was a world of applets, which were later deprecated, removed, and forgotten. But at that time, they still existed. And another major thing in browser that blew my mind, and I saw it, it was not in 2006, but a bit later, that was jQuery. It was a new approach to the language, to the way how it's used. And the trick was to apply clean design to understand what we actually are doing with a document and to describe it in a functional manner. So that was one of strongest impressions in my career. In Java world at the same time, there was GWT released also in 2006, a technology that allowed developers to stay in Java world to write Java, but to have that code being executed on client. So Java is transformed to JavaScript and it runs in browser. It was more or less clear that the time of applets ends and no one or much fewer people install Java plugins in their browsers just to run applets. But JavaScript is embedded in every browser. And Google successfully used that technology for a few of its products. Later, that became not a case. They developed different frameworks, but GWT still exists. And there are well-known technologies that use it as a part, as their part. And one of examples is Vaadin framework. That allows you basically to do the same thing, to write code in Java and to have it working as a browser program. So later, one more astonishing thing happened. Google released Chrome, powered by a very performant JavaScript engine V8. From the very beginning, it wasn't so popular as now, but you probably can easily find a diagram that shows how rapidly it grew and its usage now dominates the internet. And V8 was so good that it has been used for server-side JavaScript programming. Node.js was created in 2009. At the same time, JavaScript became alive because for many years, from the perspective of a programmer, nothing happened in the language. So different browsers developed their extensions, but then there was an attempt to have ES4 standard. It failed. So it wasn't adopted, but ES5 was adopted and it included things that we now believe are essential, like JSON. Remember that Java had its serialization from the very beginning. It's not a human readable format, but you can easily have your object transferred somewhere and it would be packed effectively, more or less effectively. But for JavaScript, you transferred XML. And after having that natural JavaScript object notation, we not only use it for JavaScript, but we now use it for Java as a default if we create the service and we don't yet understand how heavily loaded it is or what format to select to exchange the data. We'll probably pick this one, JSON. And it's supported by all major Java frameworks for web development, and it's used for configuration, etc., etc. So JSON invention was very good thing for JavaScript and for other languages as well. Same for Python or Ruby, whatever you can imagine as a modern language. And also developers have the same needs even if they program in different languages. Like we know that multi-line strings are really convenient. But by some reason, language authors may have some fears about implementing that, or it can require special syntax and there are more important things to implement. So after more than 10 years of existence, they were ready to JavaScript, but not in Java. So JavaScript started to develop more rapidly, and V8 started to get new versions that were actually new engines, I would say. But that allowed to have more heavy JavaScript code be executed in browser. So if your browser became more effective and your language standard developed, you could write less code and have it executed faster. Well, that's the thing that impressed me at that time. To write a jQuery, to have that declarative syntax and callbacks, and to almost forget about the real structure of your DOM document. You just find anything you want by the ID or its type and then perform all the animations or actions. And now jQuery occupies almost 80, so it's present in almost 80% of the all noticeable websites in the world, as well as Spring dominates server-side Java deployments or any other good technology that is useful at the time. When it was Java 7, it was a long break for JavaScript, but wait for a while, we'll see what happened next. Java versions prior to Java 9 had a long and heavy way to go. So now we have a very rapid release cadence, and that helps to track new features and to see more to see faster development of the language, of the runtime, and to support releases easier than it was before. So in Java 7, some work that can be considered preliminary to Java 8 was made. Like for scripting languages, a new internal mechanics called invoke dynamic has been introduced. But also, besides of that virtual machine preparations, There were nice syntactic sugar additions. Like finally, we are able to use strings in switch expressions. Developers hated Java for not being able to do that. I remember myself asking constantly why this feature isn't there. And I even received some smart answers. Like there are reasons not to implement it. Well, it obviously can be implemented, and it was implemented without losing any performance, because that's a relatively straightforward feature. Another thing that is more tricky is try with resources. So Java helps a developer to control errors that may appear in the program. But to perform graceful shutdown or final handling of your exception in many cases, then you need to rehandle it. In the end, you get a very sophisticated code. And this construction really solved many, or at least one, but very painful pain point of many developers. And also, language creators solved the puzzle of having too much type information in the code. Because especially after reading generics, people saw very long duplicated constructs where all typing information was too verbose, even in obvious cases. So diamond operator was, and type inference related to that operator was a big step towards having cleaner and more compact code without losing strict type approach. Also, of course, Java 7 added new concurrency stuff and things like now. Something that also existed in Node.js, but here the other aspect of JavaScript development is more interesting. In 2013, a new trend of having a very special version of JavaScript started to rise. It's ASM.js, where your JavaScript or our languages are converted into a special code, and that code was successfully optimized by engines like V8. The trick here is that we need to understand that yes, JavaScript, it has no types, but JIT compiler actually determines the types in runtime. So if it can prove that I is an integer, it will be much more effective to have an integer instead of having a full-scale map object that can be represented as string, or to have null checks everywhere. And that was one of my strong impressions. About 2010, or maybe slightly later, I heard a talk about one of Google engineers, or from one of Google engineers who participated in V8 development. And he explained how JavaScript performs that optimizations, how V8 performs that optimizations of JavaScript. But sometimes it still was better to give that specialized version of the language that is a subset of JavaScript. And browsers learned how to execute it very effectively to perform certain operations much faster compared to the case that were written in a pure JavaScript. Well, that was only a first step in that direction, first step to WebAssembly. And finally, in 2014, Java 8 has been released. And there are so many great features that we use daily. And I couldn't imagine myself without having lambdas now, because it's so convenient. Even for writing tests, you just save code that you don't, that otherwise you would have to write, and have that has no sense. Well, of course, lambdas were effectively used in streams, and futures, different types of futures were introduced in Java 8, including completable futures, so that you could combine your actual futures effectively, so you could reuse the system fork join pool. And based on the previous invoked dynamic work, Java had a new JavaScript engine called Nashorn that shown better performance than Rhino, and it utilized the idea of combining your if statement and function calls to have an effective interpretation and JIT compilation of the code of a different language. So this engine was written in this modern Java to prove that all this mechanics works effectively. And also in a type system, Java 8 introduced annotations on types. So metadata not only for classes, but for the types used anywhere in the program. Well, still that approach was developed much further in languages like Kotlin, where you have clear notion of nullability of not nullability. And for Java, we have probably a dozen of different nullable and not null annotations, and still no standard one. Well, but maybe it will be created. At the same year, many JavaScript developers, or at least Microsoft, realized that it would be actually good to have types clearly written in your JavaScript programs. And that's how TypeScript appeared. And here, it's of course interesting that it is an extension of JavaScript, and it's compiled in itself and finally compiled in JavaScript. So it's a kind of statically compiled, statically desugared syntactic sugar on top of JavaScript. Yes, you have to write more code to clearly put all your types, but well, it's more safe. V8 has been developed even further, but a year after Java 8, a new version of ECMAScript specification, ECMAScript 6, was released. And that's the JavaScript more or less everyone uses now, where you distinguish between var, let, and const. You use string templates finally. Everyone would expect that this feature is in JavaScript because it's so natural for scripting languages. But there are more sophisticated features like destructuring or finally lambdas that are relatively easy and simple to operate. Iterators, generators, promises that are not same as futures in Java, but they later were used for async and await, but they are a concept, a separate concept. And that version of specification also introduced classes. So the language where everything is a function still has everything as a function, but it can be described as a class because everyone's used class syntax. And it's easier and it takes less space to write that code if we use classes. And the funny part that besides of having every object as a map class was actually introduced at that time. Why is it necessary in JavaScript? Well, because of right and convenient operations that you could perform on maps. So different enhancements, and here the second example is more interesting to me, where we deconstruct an object to its fields, and we'll see later something similar in Java. So after that, the evolution of Java, as I mentioned, became much more rapid. And the same happened to JavaScript. After IE6, new specifications now are released every year. And for Java, we have 2 releases a year, which is really fast. And it allows us to track changes and to have smaller changes without waiting for years. So in TypeScript, there are not only types but also generics, which makes it very similar to Java. Well, it's still not JavaScript, it's a superset of JavaScript, but it's peculiar that people who have legacy JavaScript code easily combine it with a code which is much more type safe, that has generics, and it's all the same language. AwesomeJS idea has developed to a special bytecode instead of a funny subset of JavaScript, which is a very similar, it's basically the same idea as Java bytecode and other bytecodes. And that WebAssembly bytecode is effectively executed by different browsers or different JavaScript engines. But having that effective code, other virtual machines like Java Virtual Machine can be implemented on top of that. And there are few of them. TVM is probably more interesting, but there are 2 others listed here. And you can use a framework and write more or less standard, and write a standard Java code that uses that framework. And in the end, you get the code that runs in browser. And it runs not as a code that you are not aware of. It's a kind of a safe code because it's a WebAssembly, which is limited to what it can do. Unlike regular JavaScript, it can be optimized better, and it's limited in what it can do, what it's allowed to perform. By the same time, Java 10 got another gem in it. It got a var keyword, where type can be inferred for the left side of the expression. So you don't have to write the type of a variable. You just say var, very similar to JavaScript, but it's a typed var because on the right side of the expression you have something that's clearly returns you the type that can be calculated, can be inferred. So Java became very modern, and it was time to remove CoreBar that existed for 20 years. And that's now the second long-term Java version, Java 11, second long-term supported Java version. And as you know, there are 3 LTS versions, Java 8, Java 11, and Java 17 at this time. But soon there will be 4th version that should become an LTS. An LTS is something being provided by OpenJDK vendor. So in general, in OpenJDK, there's no such thing as an LTS version, but there are versions that different vendors contribute and agree to support for a long period. And if you think about code in browser, it typically makes requests via HTTP, and it uses encryption, probably it's HTTPS. And so Java finally got an HTTP client built in 2018, which is also able to perform modern encryption with TLS 1.3. And older TLS has been deprecated. So it is an important feature for programs that do the same thing as JavaScript programs on your web pages. And also you can execute Java code as a script. Like many other languages that just require you to call the main language interpreter and pass the source code, Java is now able to do that as well. And Nashorn engine has been deprecated in Java 11. But, well, what appeared instead of that? We'll see that a bit later. Well, let's also look at new things that were added to JavaScript during the period from 2016 to 2018. Async await. It's peculiar that JavaScript threading model is still mostly single-threaded. There are some asynchronous things that can happen. But even those things that is not so frequent are very convenient to use if you can combine them and not to wait different asynchronous events one after another. So you can have that promise all, and you can use async await to basically write your code without introducing many callbacks. You just work with the variables. Surprisingly, the second surprise about strings, JavaScript didn't have string templates for a very long time, and it didn't have named groups for regular expressions for a very long time. So we were added quite recently in 2018. There are also some service functionality that mostly are used in Node.js, like shared memory. Well, I can imagine that they can be used in browser as well, but that's probably not the case. And some funny things like trailing commas. There are different places in JavaScript where you now have the trailing commas, like in arrays where you list your elements, or in function parameters. Why is it so useful? Well, because we look at diffs, we look at git blame, and if we add a parameter or an element, it's not always good to change the line that's not related to our actual change. We just add or remove something. So this is how your version control system influences your language. Getting back to the removal of JavaScript engines from OpenJDK, we can now find another JVM or a JDK distribution that implements that functionality. In 2019, Growl VM release version has been made public, and it supported ES6 better than previous JavaScript engines in OpenJDK, and now it supports WebAssembly as well. And at this time, there's a call for votes for Project Galahad that's about including Growl VM into OpenJDK to have both native image functionality and other goods that Growl VM can bring. And there's a new release cadence of Java. We can now see some features being previewed, not being available by default, and the implementation can change, then JDK version changes. But nothing was removed so far, so we can see just the development of features and to try new functionality ahead of it being officially released. And such things here are like switch expressions or text blocks, and some feature can have multiple previews. Currently there are features that had four previews. And the development of language goes to the direction where developers write less and less code, and they don't need additional frameworks or libraries to perform routine tasks. Like, for example, records were introduced and made the usage of Lombok obsolete, because your runtime can generate hash code and equals for you. You don't need IDE or a library for that, but that has to be stated on the source code level. And so are switch expressions that allow you to express your switch logic much shorter than before. And in 2020, JavaScript finally got big integer support that existed in Java for ages. Why? Because people, well, do need that on the server side scripting, JavaScripting, or even on client side. Java 9 introduced modules, and about the same time modules were introduced in JavaScript, but now they can be imported dynamically. So there are imports and exports looking quite similar what you can find in Java. And the concept of promises still is being developed in JavaScript, and you can see that new things are really similar to what happens, what you can see with completable features in Java. So it's a good design being borrowed by different languages. Another funny thing is that for each for in order in JavaScript wasn't well defined, and it happened that different implementations really behave differently. So the thing that was specified or is specified for different structures in Java from the very beginning. So I mentioned Growl VM, and it's a project that implements the JVM mostly in Java, and it supports different other non-JVM languages. It's able to execute them effectively, showing a great performance, and to provide an interoperation between Java or other JVM languages code and that non-JVM languages. And JavaScript is one of such non-JVM, originally non-JVM languages. So here are examples, and if I would erase some types, you probably won't be able to distinguish which one is Java and which one is JavaScript. So first we call some JavaScript code from Java, and this is a very short way of doing this, like compared to what it required in Nashorn. There are only 4 lines of code, and in Nashorn it would take many more lines of code. Well, mostly related to the context setup. And the second 2 lines represent the way how Java objects can be created and used in the JavaScript code, which is also very convenient. There are some wise limitations on what you can actually do, what Java objects what Java functionality you can use from JavaScript, so keep it safe. But for basic things, you won't notice any problem. So for the very recent versions of Java and JavaScript, there are now sophisticated syntactic options, like different kinds of pattern matching and sealed classes for JDK. This is a movement towards algebraic types, where you can easily define some structure of types and operate matching on these types very easily. TypeScript was rather straightforward. It just declared union, and it has other options. JavaScript moves towards better boundaries for different access types for classes and their members. So you can now much easier declare private members. You can much easier declare or have an inheritance to use constructors to declare fields at all. So you don't have to declare them in constructors. Surprisingly, in the ES6 version of classes, you had to put everything in constructor. So now it's much more like Java. I mean, JavaScript became very similar to Java. And in Java, you have even shorter code for the things that we historically had as a boilerplate that we used to see. Like if we have a switch or many ifs and we have instance of checks, well, it's Java, it requires many words to describe how it works. So in JavaScript, we can see classes that are very similar to ones in Java, except we don't write that long keywords like private. We don't write it, we just put a hashtag here. And in Java, many things are still in preview, but there are chances that they will be settled before or in the upcoming LTS version. One of them, or one of the new functional things that we've previously seen in JavaScript is the structuring of records. So we can get different variables linked to fields of a record in a certain context. So here the context is clear. We have an instance check, and then we can extract that fields. And then we work the different types. There's a button switch where we can introduce new variables that correspond to different types that we match to. So that's the kind of code we write a lot, and it's a pain in Java. Now it becomes not a problem. Okay, I hope that wasn't too long, and we'll have some questions to answer.
Okay, does anyone have any questions here for Dimitri? You can type those in the chat window if you do.
I don't know that you folks can hear me, but Mr. Dimitri, can you compare and contrast the new Java that you explained the whole thing with where C++ has in its journey? And can you compare and contrast that?
Well, what exactly do you mean? Like new standards in C++?
Now, how far as C++? So one of the things is Java doesn't do, you can't do multiple inheritance, right? I mean, that's one of the basics tenets on which Java came in. I learned Java because of that. But, function pointers and all those things, C++ had all those things. And is that making its way into Java or no?
It is. So there are multiple ways how these things make their way to Java. So first, if you mention functional pointers, there are now method references since Java 8. That's a direct but safe analog of such functionality. Another approach is calling real native, which is C++ or other statically compiled languages libraries. And Java now has a foreign function interface. It's still being developed. I didn't mention it on slides. I think some part of it is now at final version. That's probably some part of foreign memory API.
Is that like JNI 2.0?
Yes, but it's much more lightweight than JNI. So JNI allows us to make very complex things. So we can pass real Java objects to native code, and it can operate the Java objects, and it makes us to perform many checks and to deal with save points very accurately. And new approach is to create all that native objects in native memory. It's a kind of in the middle between safe and unsafe, because we manage it very carefully from the safe code, but we end up with this memory being totally native code controlled. And then after native code finishes its work or returns this memory to us, we can map it back, read it, and create safe objects. But that happens inside our safe Java code. It doesn't require JNI.
Thank you.
All right, any other questions?
As there are questions about the presentation, yes, I will share that. And
Can I ask a
probably
very strange question of the origins of like JavaScript and Java? Java came from a very standardized group, the JSRs, and they were very correctly created. Now, JSON is not really, or JavaScript is not that way. It's like the wild sides. It's very wide. Can you talk about that?
well, I don't think it is bad, because we have that very strictly defined, fully backward compatible language. That was a bit harder to operate. I mean, Java.
Mm-hmm.
And now it's being developed to be, well, much easier to operate. But the process is very slow. But in the end, we see that the code becomes simpler. It becomes shorter. We can omit unnecessary ceremony. But the movement is very accurate. And I like this approach. But it didn't work well for the cases when people needed to write code fast, maybe to write it once and never read it. That's where JavaScript played very well. And after all, the JavaScript library ecosystem became one of major library ecosystems in the world. I'm not sure, probably npm repository is bigger than Maven Central. I may be wrong here, but at least they are comparable for sure.
Well, there's more innovation on that side. I agree. But it's not standardized very well.
Yes, and then there's a problem. We have all the great libraries, but maybe we'll try to write good code that uses that libraries, or have means to write good library code, or better than it was before.
Mm-hmm.
That's, I think, is the direction of JavaScript development.
I hope so. But thank you.
Thanks. Yeah, interesting question about Java in AI world. Yeah, I think Java is going to compete in AI world at least a little. It would be hard to do so, of course. But with all that new means of calling native libraries, of having optimizations and virtual machines that are able to automatically use proper hardware like GPUs. There's an implementation or a wrapper for a regular VM called Tornado VM that allows you to easily reuse your GPUs. That's critical for many AI tasks. Then you really calculate something. But Java lost some time here, definitely.
But that's a very good question, right? So Mr. Nick raised a very valid point. So can you, for a brief second, you compared many polyglots, Java and JavaScript. Can you compare Java and Python in a quick, maybe 2 minutes? It will really help.
Well, Python is developed in a very interesting way. So everything is an extension. Like the most recent interesting thing to me is the same as what happens in JavaScript and with JavaScript and TypeScript. So type annotations in Python. So you can have types written in your Python program, but that's an optional thing. So there are some basic runtime checks, and there are also optional compile time checks or just static type checks. You don't have to compile the program. Static type checks that you can skip. And it's a different approach. And I would add JavaScript to comparison here and TypeScript. So in Java, types are a very core part of the language. There are some difficulties like generics that are, well, erased, but you mostly have your type information through the whole life cycle of from your source code to what's being executed. In TypeScript, you check everything during the time of compilation from TypeScript to JavaScript, then you lose that type information. And in Python, you have some mix. It's not clean from a perspective of adding types, but it's very clean from a perspective of adding language extensions. So yes, Python is interesting. There are multiple ways of doing different things, powerful things. Well, if you consider data classes, their syntax is not the syntax that previously existed for classes. So if you don't know that data class is a special thing, you may think that you write it in an improper way. Then you declare fields, for example.
But you have to agree that it has taken a big bite out of the AI thing in terms of AI.
Sure. We talk about most popular languages, most popular programming languages. JavaScript, Java, Python. Definitely they are top 3, top 4 languages.
Sorry if you covered this in the beginning, but what do you think explains the all the piggybacking of features between Java and JavaScript? Is it just the natural evolution, or like are there developers that are working on both projects at the same time, or is it just like how'd that come about?
I think both are true. So you just mentioned different reasons of that evolution. I'm an example of such a developer, right? I used to write front-end code and back-end code. And it's one of solutions is to use JavaScript everywhere, right? You use Node.js and you use JavaScript on your web page. Another solution is to use Java everywhere, right? You can use Vaadin and write your JavaScript backend and use Spring. Or you can try to select subsets in both languages that are close enough to look very similar. One of very typical examples, validation. Everyone hates to write same validation both on client and on the server, right? You need exactly the same code and you have to watch it to be correct and to actually perform the same checks. So yes, it's the convenience of maintaining such a combination, but also in every language independently, creators just help to reduce the boilerplate.
But some of these boilerplates created safety in some ways to ensure that the interfaces, like schema and XML, now there's schema in JSON, and therefore it helps to get the interface correct. It removes most of the checks, but not all of the checks. And that's the difference between a good interface and a bad interface.
Yeah, I would agree. Sure.
Mr. Peter, I think you brought up a very good point, right? So by having these schemas, isn't that why SOAP actually died? because you had to do a lot of this type information inside us, the schema information inside every call that we make. And isn't that why it got defeated ultimately and REST took over?
Yeah, but it's an agree for both sides, the client and the server, because most of the time it's not on your company because you create public stuff. And therefore you have to create all the stuff in there, document and everything. But if you have an interview in the vet, it works that way. It's better to help the people.
Yes, now there's it became easier than 20 years ago. Like for XML, you had, or you still have that schema validation, but for JSON you have options. You had options at that time too, and here where frameworks helps. Like you have Swagger, right? And that really helps to create the API and to specify the schema without, well, hard efforts.
But one thing, sir, one thing I have to say, JSON is all great. JavaScript is fantastic. Yet till today, they could not say we'll introduce comments inside of JSON data. The biggest hurdle is no comments. I mean, real pain in the neck.
Yes, you can use some pre-processing, of course, but yeah, that's the thing that's missing.
Oh, I do. I have a lot of grep and awk scripts which do that for me, but yeah.
Okay, well, if there's no more questions, then usually if we were in person, there's generally a big round of applause here for our speaker. So thank you very much here, Dimitri, for a great presentation. So at this point, I think I'll see if I can go ahead and stop the recording.
All right. May I answer one more question?
Oh, go ahead.
Java skills in 2023. I would say definitely containerization and native images. That are things that we are going to use daily.
Okay, yes, those are definitely important skills. Well, thank you very much, Dimitri.
Thank you.